Assalamu alaikum. Today we will discuss about the generation 4 gas cooled fast reactors. I am Mohammad Tokir Ahmed on behalf of Group 1, roll number 1 to 10. At first, let's have an overview about today's contents of discussion. First, we will start about giving some basic information on gas cooled fast reactor. Then why gas cooled fast reactors has been introduced. Then we will discuss about some information of generation 4 GFR system, and we will show an illustration of proposed 2400 megawatt hour indirect cycle GFR. After describing some challenges to implement the GFR, we will conclude. So what is a gas cooled fast reactor? A gas cooled fast reactor system is a high temperature helium cooled fast spectrum reactor with a closed fuel cycle which will use a direct Breton closed cycle gas turbine for high thermal efficiency. The GFR was chosen as one of the generation 4 nuclear reactor systems to be developed based on its excellent potential for sustainability. The sustainability will be obtained through reduction of volume and radiotoxicity of both its own fuel and other spent nuclear fuel, extending or utilizing uranium resources orders of magnitude beyond what the open fuel cycle can realize. So why a gas cooled fast reactors has been introduced? The fast reactors are important for sustainability of nuclear power. We know that fast reactors occur more efficient use of fuel, reduced volumes and radiotoxicity of high level wastes. We know that sodium cooled fast reactors are shortest route to fast reactor deployment, but it also has some undesirable features. The sodium cooled fast reactors has chemical incompatibility with air and water, the strongly positive void coefficient of reactivity, avoiding sodium boiling places of restriction on achievable core outlet temperature. But the gas cooled fast reactors do not suffer from any of the above. The coolant, that is helium, is totally chemically inert. Void coefficient of GFR system is too small but still positive. Single phase coolant eliminates boiling. But we know everything has a dark side. Gaseous coolants have also some disadvantages. Gaseous coolants have little thermal inertia. It have rapid heat up of core following loss of forced cooling. It is compounded by lack of thermal inertia of core structure. It is very high power density. It has very high power density. The motivation behind gas cooled fast reactors are enhanced safety and improved performance. Now we will see some information about generation 4 GFR system. These are some parameters and reference values, and this is a simple illustration of generation 4 GFR system. This illustration is for the helium coolant. For helium coolant, the inlet coolant temperature and temperature is 490 degrees Celsius and outlet temperature is 850 degrees Celsius. The pressure is 90 bar. Average power density is 100 megawatt hour per meter cube. The net efficiency is about 48%. The cylindrical vessel with upper and lower spherical pores contains the core. It also contains the internal cylindrical shell which separates the cold zone from hot zone. There are 3 main heat exchangers and 3 heat decay removal exchangers. In this proposed GFR, no moderator is needed to slow neutrons down. That means we can use other fuel along with uranium such as plutonium and thorium, etc. Silicon carbide fiber reinforced silicon carbide cladding and internal refractory metal liner is required to prevent diffusion of fission products through the silicon carbide or silicon carbide free radical cladding or fusion of flow of fission products through microcracks. Let's have a look on some the challenges to implement a GFR system. First, fuel and core. The greatest challenge facing the GFR is to develop a robust high temperature refractory fuels core structure material. It must be capable of withstand the in-core thermal, mechanical and radiation environment. Safety and economic considerations demand a low core pressure drop which favors high coolant volume fractions. Minimizing the plutonium inventory leads to a demand for high fissile material volume fractions. Candidate compositions for fissile compound include carbides, nitrides, oxides. Favored cladding materials include refractory materials, silicon carbide for pin formats, and ceramic matrices. Then the challenges on the selecting materials. The material should be resistant to corrosion, especially the materials of cooling circuit, heat exchanger, insulation and sealing. GFR system has relatively high pressure in primary circuit and relatively higher efficiency circulators. Rapid heat up of the core following loss forced cooling due to lack of thermal efficiency, high power density, high coolant velocity in the core, the leakage from the system, the recycling and chemical control, difficult decay heat removal in accident conditions, relatively high temperature around the fuel rods. These are the challenges to meet up on the selection of materials to implement the GFR system. Decay heat removal, the HTR conduction cool down will not work in GFR due to high power density, low thermal inertia, poor conduction path and small surface area of the core conspire to prevent conduction cooling. A convection flow is required through the core all the times. Normally natural convection flow is preferred during shutdown, and it is possible when the circuit is pressurized. But when the circuit is depressurized, there is a need of forced flow. Forced flow required when gas density is too low to achieve enough natural convection. Power requirements for the blower is very large at low pressure. The primary circuit must be reconfigured to allow decay heat removal. Main loops must be isolated. Decay heat removal loops must be connected across the core. Now we conclude by saying that the motivation behind GFR is to develop a fast reactor system that is free of the worst problems associated with the liquid metal cooled fast reactors, and the advantages of GFR over liquid metal cooled gas reactors are the coolant, that is helium, is chemically inert, the excellent nuclear stability avoids activation of the coolant, the transparent coolant permits simple inspection and repair. So this is the discussion about a gas cooled fast reactor, and thank you for your attention. Assalamu alaikum.